And you can see we have another problem on the same concept. And in this diagram, C1 equals C by 3, C2 equals 2C by 3, E1 is greater than E2. Find the change in charges delta Q1 and delta Q2 of the capacitors with capacitances C1 and C2 after closing the switch. So now when the switch is open, there are charges on the capacitor. Since only C1 and C2 are connected and they are in series, you can write charges on them as Q1 and Q2, and since Q1 equal to Q2, you can write them as the voltage source is E1 minus E2 because E1 is greater than E2. So charges on being E1 minus C2 and multiplied by equivalent capacitance in series, that is C1 C2 by C1 plus C2. If you put the values C1 equals C by 3 and C2 equals 2C by 3, you will get the result as 2 by 9 C E1 minus E2. No problem at all. And now after closing the switch, since we need to close the switch, and after closing the switch we can draw an equivalent circuit, and I'm willing to draw one. That is like so. I'm watching it closely. C1 and that's E1, C1 E1, and there is something C in between because switch is closed, and then C2 and only the terminals. Yeah, this is E2 and this is C2. This is the circuit before you, and now you need to solve the circuit because you have got a clear-cut circuit. Suppose I put charges after switching the key to closing the switch. We have charges on C1 and C2 as Q1 dash, Q2 dash, and the charge on C as Q3 dash simply. Then I guess we have a circuit and we need to solve the circuit. Just arbitrarily I put charges on here as Q1 dash minus Q1 dash, Q2 dash minus Q2 dash, Q3 dash minus Q3 dash. Then I can isolate the plates and simply write the equation as Q1 dash minus Q2 dash minus Q3 dash is equal to 0. And also we can, if we can start from here and go to here, we can write after passing through this we will gain a potential difference equal to E1, that we can write from here to here, and I first need to move from this point to this point, and moving from this point to this point will be a gain of potential A1, and after moving from this point to this point we will lose a potential equal to E2. And if we do the same from this point to this point, we are going to gain the potential here as Q1 by C1, and from here to here as this was basically Q1 dash, Q2 dash by C2. On that we have two equations, but we need one more. So I'm planning to move from this point to I want to move in a full circle. That means I would like to move in this right hand side loop. And so if we can start from here, from this point, to get to this point, we will get a potential equal to E2, and then we are going to lose here by an amount Q3 dash by C, and then we are going to get, that is Q2 dash by C2, and again come to the same point, that is equal to E2 again at that same point, that is equal to 0. So I guessed we have a potential here at something that is X, and we move from here to here and gained E2 because we are moving from lower potential to higher potential, so we gained E2. And then here from higher to lower, so we lost Q3 dash by C, and here from lower to higher, that means we gained Q2 dash by C2 and reached again to the same point X. And that is why I would cancel X from both sides, and I can write the equation that E2 equals Q3 dash by C minus Q2 dash by C2, and this is our equation 3, and we can solve all of them to get Q1 dash, Q2 dash, and if possible Q3 dash. But I need to solve this problem only for Q1 dash and Q2 dash because the problem is asking only the change in campus, change in charges on the capacitors C1 and C2 only. So I need to find out Q1 dash and Q2 dash only, and so I got Q1 dash equals C by 18 after putting all the values, 5 E1 minus 2 E2, and Q2 dash as C by 9 E1 minus 4 E2, and so I got delta Q1 equals Q1 dash minus Q equals C by 18 E1 plus 2 E2, and delta Q2 as Q2 dash minus Q2 equals minus C by 9 E1 plus 2 E2, and problem is being solved. And thank you very much for watching.